Great to see you here. My name is Luc de Custer, founder of the Custer Academy. If you're here for the first time or you came back, you have been enjoying our videos but you didn't subscribe yet, this is the moment to click the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you. In this video I will talk about a special application of congruences, which is in fact the check bit. We want to verify if certain series of numbers, sequences of numbers are correct. And in order to do that, we have in fact what we call a check digit that is added at the end of the number. And that check bit is going to verify if the formula that we apply on the number is congruent a specific modulus, modulus 2 or modulus 10, depending on the application that we are using. Now basically we want to see that these numbers are correct, and the numbers are following special rules. I'm sure you may have seen these things already in your daily life. When you buy something, think about buying a product in the supermarket where you have a barcode which is a series of numbers translated into a set of bars with different thickness and different distance that can be scanned by a barcode scanner. And that code, that product code, typically is linked to a producer, a country, and a specific product. So you can identify those products. When you put those barcodes, those numbers into your POS system, in your point of sale system, every time you scan that barcode, you will see that it shows the description of the product and the price and other specifics that you may need. So it's a very interesting application. We find barcodes on all kinds of things, also on let's say the papers for sending items, shipping documents, things like that. They're used in a lot of applications, and you can find the standards in the GS1 standard. You can find it on the internet, and once you are confronted with them, you will understand how useful they are, but you have to follow specific rules. What are some examples? We have bank accounts. When you have a bank account number, that bank account contains also some check digit to be sure that the combination of numbers that you're using is basically correct. We have bit sequences that we can consider, and we want to look at the parity. The parity refers to the number of bits that are equal to 1. Is it an impair parity or a pair parity? Those are the things that we are going to verify, and we can verify if the sequence that we are considering is correct or not. We have the universal product code, which is a 12 digit, let's say 12 number code. We also have the EAN, which is the European article number 13 or 18. 13 contains 13 numbers, 8 is a reduced version that can be used on smaller products. Now we will look into those different things in the remainder of this presentation. Like I said, they're following the standard, the GS1, and there you can find all the different applications. There is even an EAN 3 and an EAN 5 and an EAN 2, which have special applications in combination with other of those EANs. Something you may already have seen, I'm sure, when you have your books from school, you look at the book, there is a barcode on that book, and that barcode is an ISBN code. It's an international standard book number. We have it also for ebooks, we have it for different type of publications, all standardized and applied on everything we find today. Whenever you find a barcode, you know there is a check digit, there is a standard describing this. But let's first have a look at the application of the parity bit. The first application relates to the parity bit, and the parity bit is applied on bit strings. Bit strings are strings of binary numbers, so we have a sequence with the size of n, and every number, every element of the bit string xi is between 0 included and smaller than 2 not included. Basically, the bits can only have the values 0 or 1. When we have a bit string here with n bits, we have x1, x2, xi up to xn, and at the end we have to add the check digit. Now the check digit we have to calculate using the modular formula. Since we here have, let's say, the maximum is 2, so basically we have to calculate this sum modulus 2. Now what we have, the parity bit, so xn plus 1 is equal to the sum of I going from 1 to n of all those bits modulus 2. Now what do we have here? Well, let's have a look here. We have this bit string 1, 0, 1, 1, 0, 1, 1, 0, 1 and 0. So when we make the sum, we have 1 plus 0 plus 1 plus 1 plus 0 plus 1 plus 1 plus 1 plus 0. So basically we have those 9 numbers, and the 10th number will be the check digit, or the parity bit in this specific case. Now we have 1, 2, 3, 4, 5, 6. We have a pair number of bits, so we have 6 modulus 2, and with 6 modulus 2 we can say that the parity bit in this case is equal to 0. So when the parity bit is 0, basically it means that I have an even number of bits which are equal to 1. If I would have an uneven or an odd number of bits, the parity bit would be equal to 1. That's a simple way to find out if the parity bit is correct, or how to calculate the parity bit. On the other hand, we can find a way to verify if the string that we received is correct. So we received this string 1 1 0 0 0 1 1 1 1 1 0, and now we have to say, is the parity bit that we have, is that parity bit correct, or does this parity bit correspond with this string? Now we have to just calculate everything. We know that x11, the parity bit, is equal to 0, and we add all the bits together, and we find that we have a total of 7. 7 modulus 2 is equal to 1. So this means basically that in our case something is wrong. The string that we have doesn't comply with the parity that we found here. We expect an even number of bits equal to 1, but we have an odd number. Now the parity bit is very interesting, but there is one thing you have to remember. It only verifies the parity of the bit string that has been sent. Is it even or odd? It doesn't say anything else. You can have a parity bit which is compliant with the bit string that was sent, although the bit string is not correct. It's just verifying the parity, and that's all. But it's already a very important element to be sure that the data you received are probably correct. Let's have a look at some other codes like the UPC and the EAN codes. Let's now have a look at the check digit when we're using the universal product codes or the European article numbers, the different possibilities that we have. First, we look at the UPC code. The UPC code is composed of 11 digits, 11 numbers between 0 and 9, with a 12th number, which is the check digit. Now, when we look at the standardization, how this is working, everything is built conform a specific algorithm, a specific rule. And for the UPC code, we first have the product category. The product category specified according to the standard. Every product has a specific category. So when you're selling specific products and you want to have the UPC codes, you have to use the correct product category. You are registered as a manufacturer, and every manufacturer has a code, and that code is from X2 to X6. Those code numbers represent the company that's producing these products. The next, from X7 till X11, is the specific product code, the product that you're creating within your company. So every product has to have a specific number. And finally, we have the check digit that we have to calculate based on a modular calculation or based on a congruence. Now, how are we going to do that? How do we find the check digit? First, we take the odd parameters, x1, x3, x5, x7, x9, x11. We multiply them with 3, and then we add the even parameters, x2, x4, x6, x8, and x10, plus the check digit. And that has to be congruent 0 modulus 10. So basically, when we have this calculation plus the check digit, we have to have a multiple of 10. This we call the checksum. So the sum of all these numbers that are part of the UPC, those 11 first numbers, we call it the checksum. And when we look at the checksum plus x12 has to be congruent 0 modulus 10. So basically what we find when we have the checksum, in this case we find 85, we have to add the number which goes to the next multiple of 10. 85, the next multiple of 10 is 90. So basically when we have a checksum of 85, we have to find, or we have to add 12 as the check digit. Let's do some exercises based on the UPC coding system. Let's now verify if the number, the UPC code 3521733143229 is correct. What we have to do? Well, we have to start from the left to the right, and we have to multiply all odd positions with 3. So I start 3 times 3 plus 2 plus 7 plus 3 plus 4 plus 2, and now I add all the even positions, 5 plus 1 plus 3 plus 1 plus 3 plus 9, and is this congruent 0 modulus 10, or is this number divisible by 10? So let's have a look. We have to have first 3 times 3 plus 2 is 5 plus 10 is 15, 15, 19 it's 21, and here we have 5, 6, 3 and 1 it's 10, 3 plus 9 is 12, so we have 22, which gives us 63 plus 22 is 85, and we say that 85 is not congruent 0 modulus 10. There is a problem here in the check digit that we have, and we can find it quite easily. What should be the check digit? Well, take away this and we look at the checksum. Without the 9, checksum is equal to 85 minus the 9 is 76. So 76 plus 4 is congruent 0 modulus 10. And then 4 would be the correct check bit, so check digit. So this has to be 4. Basically what we find here is a control before we start creating bar charts and all those barcodes that the number that we are considering is correct. Let's now do an exercise using the UPC coding to create the number to find the check digit. Let us consider this new number, this UPC code, 57327419783, and we have to find the check digit. The first thing that we have to do is to calculate the checksum using the formula that we've seen before. So we start from 1 here, so we have 5 times 3 is 15, we have 7 times 1 is 7, we have 3 times 3 is 9, we have 1 times 2 is 2, we have here 3 times 7 is 21, we have 4 times 1 is 4, 3 times 1 is 3, 9 times 1 is 9, 7 times 3 is 21, we have 8 times 1 is 8, and the last one is 3 times 3 is 9. So based on this I can calculate the checksum. And the checksum is equal to all those numbers here. So I have 15 plus 7 plus 9 plus 2 plus 21 plus 4 plus 3 plus 9 plus 21 plus 8 plus 9, and I find this is 108. And what do we have to do to find the check digit? So we have the checksum plus x12 is congruent with 0 modulus 10, which gives us here 108 plus x12 is congruent with 0 modulus 10. So we have to add a number to 108 x12 to make it a multiple of 10. So basically this is 2, and the check digit that we need to have here is 2. So the final number that we will code in the barcode is 57327419783 and 2. So that's the way we work with the UPC code. Let's now have a look how we do it with the EAN code 13. The EAN code 13 is similar to the UPC. We now start from 12 going to 0, and the even number starting from right to left in this case, so the highest number 12 is in fact the first number of the EAN code. Now when we are looking at this, we are going to do the same multiplication. So what we have to do is to add those multiplication, and I find here 5 plus 18 plus 2 plus 3 plus 3 plus 3 plus 4 plus 15 plus 7 plus 27 plus 2 plus 27, and we make the sum. This is equal to 115. The rule that we apply here to find the check digit is in fact basically the same rule. So this is the checksum, and we have checksum plus x13 is congruent 0 modulus 10, and the checksum is 115 plus x13 is congruent 0 modulus 10, which brings us to the x13 to bring 115 to the closest value of a modulus of a multiple of 10. So this is then basically equal to 5, because 115 plus 5 is congruent 0 modulus 10, and we can say the number here goes to here, and we can say this is 5. So basically this is the complete format for the EAN13 code. Let's do the same now for an EAN8 code. This is now an example where we're going to find the check digit for the EAN8 code. We can use the same procedure to verify if a specific check digit is correct. Now we start from 7, 6, 5, 4, 3, 2, 1, and 7 coefficient 3, the pair numbers 1, and so on. Our EAN8 number is 5619324. And there's one thing I forgot to say when we were looking at the EAN13 number before. When we compare this with the UPC number, the EAN number has a small difference. Remember that in the UPC code, the first number was a product code. In the EAN system, the first code, the first 2 or 3 numbers indicate the country of origin. So if you have a barcode and you have the EAN13 or the EAN8 code, you can identify where the product you're buying has been produced. Interesting, isn't it? Very easy to find. Also, when you put the code in the internet, you Google it, since everything has been according to international standards, you will be able to find the country of origin, the manufacturer, and the product that we are talking about. All these things because everything has been standardized. But let's do the calculation here. 3 times 5 is 15, plus 1 times 6 is 6, plus 3 times 1 is 3, plus 1 times 9 is 9, plus 3 times 3 is 9, plus 1 times 2 is 2, plus 3 times 4 is 12. So in this case, the checksum is the sum of those. It's 21, 30, 33, 42, 42, 44, 56. And we find here that the checksum is 56. Now we know that the checksum plus the check digit x0 has to be congruent with 0 modulus 10. It means we have 56 plus x0 is congruent with 0 modulus 10. It means that x0 is equal to 4, and we can put this number here as the last number as the check digit. So that was another example. Remember, EAN13 and EAN8, they're basically similar. The only thing is that we use the EAN8 when we don't have enough space to put an EAN13. If you're interested in all those standards, in all those barcodes that exist, you can find it on the GS1 website. It contains all the possibilities, and it's quite interesting if you want to send items around, if you want to identify or create your own barcodes. It's no magic, it's a simple procedure, country, company, product. Once you have those, everything is set. Let's have a look at another application, which is an extension of the EAN13, is the ISBN number. And in the ISBN number we have 2 types, the ISBN 10 and the ISBN 13. They're a little bit different, and most of the time you will find today the ISBN 13. Let's have a look at that. The last exercises for this video are related to the ISBN 10 and the ISBN 13. Both are using the modular arithmetic, although for the ISBN 10 we will be looking at modulus 11, and here we look at modulus 10. The ISBN 13 is built in the same way as we built the EAN 13. Now we have also different coefficients, so we start from the left to the right. So we have the coefficient 10, 9, 8, 7, and so on. So we go from 10 till 1, which means that we have about 11 numbers. The numbers are also a little bit different. So this is an ISBN code that exists. I found it somewhere, and now we can do the calculation. So we have 10 times 0 is 0, 3 times 9 is 27, 8 times 0 is 0, 7 times 6 is 42, 6 times 5 is 30, and 5 times 9 is 45, 3 times 4 is 12, plus 6 plus 8, so it means that the checksum in this case is equal to, if we add all those numbers, we find that this is 170. And we have to find that 170 plus x0 is congruent with 0 modulus 11. And when we look at that, we find that x0 is in fact equal to 6, because 176 is 0 modulus 11. So that's the 10 ISBN code. It's an older code, and when we look at the ISBN 13, it's a little bit different. So we have 9 times 1 plus 3 times 7 is 21, plus 1 times 8 is 8, plus 3 times 8 is 24, plus 0, I like that one, plus 6, plus 5, plus 12, plus 8, plus 21, plus 0, plus 21. And we look here, the checksum is equal to, when you add all those numbers, you find 135. So basically we can say that 135 plus x0 is congruent 0 modulus 10, that in this case x0 is equal to 5. Now when you would put this ISBN number into the web browser, you say 978-802-548-707 and 5, you will see what this ISBN number relates to. So that was it for the check digit, the parity bit, all these things, very important elements to verify when you receive sequences of numbers that these numbers are correct. Don't forget to have a look at the text below the video, links to our courses, great coupons for great discounts, and if you didn't do it yet, it's the moment to click on the subscribe button, click on the bell button, and I'm looking forward to seeing you the next time. Thank you and bye-bye.